Today we are going to do work.
Yay!
It's generally planned.
And researching the air system more, putting stuff on the product sheet.
Hello, my name is Leo, and welcome to KSPB Pebble Beach at 91.9 FL. Welcome to the Stevenson School Robotics Lab, and this is Ollie, one of my co-heads at Stevenson Robotics, and we're going to talk about what we do as robotics people. So this is called a vertical profiling float, and its function is that this is basically a small submarine that will go into the pool, sink down to the bottom of the pool that mimics the ocean, and it floats back, recording data of depth, pressure, and time. Right now, you can see that the vehicle is disassembled, and I'm going to assemble it, and I'm going to show you some of the key features. So the top cap is a flank, and then it has some O-rings to make sure that this area is completely sealed without any water damage. On the bottom, as you can see, we also have a lot of O-rings. And then we'll screw the part in to make sure that the 3D printed red filament is completely attached to the acrylic tube. When this syringe pushes water out, this thing becomes less dense and it flows onto the surface. And when the syringe draws water in, the vehicle sinks down. Some of its key design features is still the waterproofing capability of it, because we cannot allow water to get in and damage the electronics, such as the linear actuator. So we have put a lot of glue on it, as well as O-rings, to make sure that this thing is safe to maneuver. And it is 2 buoyant. So we have put some weight in there. It's stainless steel balls. And then we install it on the bottom of our vehicle. Also screw it on. And this is one of our main philosophy on dealing with robotics. It's called prototyping. As you can see that we have a lot of 3D printed material that might not work in the beginning. And this is how we find out the problems and then redesign it, reprint it, and make them better. So as you can see that we tried many times in order to make the perfect design that we will use in our vehicle.
We are building basically the component of the robot that grabs objects. And the thing about the actuator is that it needs to be strong, precise, and reliable. So it's a little bit of a difficult task, but essentially our team's actuator is built around this, which is a single action round body pneumatic piston. And basically what that means is that when pressurized air is routed into this inlet, it retracts. It's like this, very forcefully. And when that air isn't present, spring basically makes it default to the unretracted position. And so our job as the actuator team is to build a mechanism around this that uses this force to close arms around an object and grab it with some amount of force. So this is our current design for the actuator mechanism. This down here is this cylinder. But yeah, we've been working on it for a couple weeks now, and we're just getting to fabricating it here on the 3D printer. Most likely we'll have to do revisions because that's kind of just the nature of robotics. A lot of times on a part you'll make a mistake, but I guess the real learning part of it is that once you make that mistake, you go back, you fix it, and then you realize, oh, here are other things I could improve. And so you improve them, and you go into the next revision, and you just do it over and over until you have something really good.